got the geometry looking really good right now on the knee. The next thing I want to concentrate on is I've scraped the two surfaces of the saddle parallel to one another, and I actually use this to scrape the top ways on the knee as well. And I've done some preliminary testing on this quite some time ago, and it looks good. But one of the things that I want to do, and the more I get into this job, the more I'm slowing down, is I want to understand when the yoke goes into the saddle, I want to pick up the center line of this bore relative to the center line where the y-axis screw is going to go. Because of the scraping that I've done, I want to make sure, I want to understand the alignment between the two pieces. As I crank the wheel, I don't want any binding and stuff, so I just want to know up front where things are. This is doweled. I mean, some guys take the dowels out and slot the holes and move these around. I don't really want to do that. I want to understand where it is and how far out it is, and determine my best options. So what I've made up is just a pin. It's a pretty good fit through here, and then the plan is I'm going to put it up on the surface plate and get some measurements. So what I've got to check this, I've got the pin inside of the yoke. I've got a tense indicator on a height gauge here, and I zeroed the indicator on actually I zeroed it on a granite surface plate. Granite's a little bit has a little bit better surface finish than the cast iron here. Just with the scrape marks and stuff, it's hard to make sure you're actually zeroed on cast iron, especially with scraping marks on it. So what I've done is I dialed in to the top of this, read it off the vernier, and then what I did was I made up a set of stack of height gauges there. And that stack is 5" 9/67, and I just used that as a verification that the height I read off of the vernier matches the height of the gauge blocks, matches the height of the pin here. So the next thing I got to do is I got to measure the pin, and then that'll give us a center line for where is the center line of the yoke relative to in this case will be the top of the saddle at this point. And then the next step is I'm actually going to put the knee on the saddle upside down on the surface plate, and then I want to check where is the center of the bore for the Y crank handle. So I did the math. This crude drawing here represents the saddle and the yoke and the pin. And the pin diameter was 1.734. The height we got with the height gauge was 5" 9/67. So the center line of that bore is 5" 9/67 minus half the diameter of the pin, which works out to 5" 100. Didn't even plan that. So now, as I put the knee on here upside down and check to position the center of the bore for the crank handle, I'm going to want to know the difference so I can figure out how concentric the center lines of the yoke and the handle are. So right now I've got the saddle sitting on the surface plate, and then the knee upside down on the saddle, and then we got to pick up the bottom in this orientation, which is actually the top of the bore for the crank handle for the Y direction. And yes, I do have the chicken strap on. It's sitting on there. Doesn't appear to be moving. That's a tense indicator. And what I'm trying to do right now is find the bottom of the bore. So as you go side to side, it gets heavier on either side. So I'm trying to find a low point. Make it 0. Which it's off by a couple of tenths there right now. So that's within a tenth now. I'm going to go a little further into that bore. There we go, that's zeroed there now. So on the vernier right now, it looks to be 4-inch 133. So I'm going to make up a set of gauge blocks at 4-inch 133. And see if we zero out on that with the indicator. That was kind of nice. 4-inch 133 is basically 2 blocks. Let's see what we get here. It's about 2.5 thou high. I'm going to make it up at 131. And basically all this is doing is it's just a verification of what am I reading. What am I reading on the vernier on the height gauge? So that's within 1/2 thou there. So it's 4-inch 130 and 1/2 thou. I'm double checking the bore diameter here, so we need that value to figure out the height of the center line. That's coming in at 1-inch 850. So when I do the math on this here with the y-axis crank handle bore here, I measured the bottom of the bore relative to the surface plate at 4" 130. The bore was 1" 850, so we take half of that and add it to the 4 130, and we end up with 5.055. And then if we take the yoke was 5" 100, and the bore 5" 055, we end up with 45 thou. So one of the things I do want to check is how parallel, as it's sitting on the surface plate here on top of the saddle, how parallel the knee ways are, just to make sure that the, just the way I have it sitting up here, make sure it's not tipped or something like that. I'm just using the dial indicator here on the height gates, and I'm checking the which would be the top of the knee, way on the top of the knee. It's not the easiest. It bounces around quite a bit with the scraping marks in the way. But it appears that the knee is sitting parallel on top of the saddle at this point, upside down on the surface plate. So it looks like the numbers on the alignment for the crank handle and the screw are good, which means there's about 45 thou difference right now between the yoke and the crank handle bore for the y-axis. And then I'm going to try and figure out how to look at the table, which would be the X direction, and the saddle, and figure out where that's at, because that's going to move as well as I scrape that in. So I got to figure out what's going to move and likely to where, and then understand what I need to do with the yoke.